y'all, welcome to Miss Clark's chemistry class. This is the 8th and final lesson in a series of lessons about nuclear chemistry. This lesson we're going to talk about nuclear fusion. We're going to take two tiny nuclei, slam them together, make something bigger. Did you know this was the chemical reaction that's happening on the sun? Well, go grab your notes, get something to write with, and let's get started. Let's talk about what fusion is. If we think about that word fuse, it's right there in the word fusion. Nuclear fusion is where we're going to take light nuclei, small, tiny nuclei, and we're going to fuse them together to make one larger nuclei. So we're going to take two small atoms, slam them together with such force that they stick together and form a larger nuclei. Okay, so we're going to slam two light nuclei together and we're going to form a larger nucleus. When this happens, it produces a lot of energy. Let's remember those strong forces we talked about holding the nucleus together. In a previous lesson, we've talked about how nuclei, protons and neutrons, the only charge in the nucleus is positive. So how do we get all these positively charged nucleons to stick together in the nucleus? Well, that's the nuclear binding energy. If we're talking about two nuclei, a nucleus is made of protons and neutrons, so nuclei are positive. How are we going to bring these two together? Same charges repel. If we can have enough energy to push these two nuclei together to overcome that strong force, the result, lots and lots of energy. Nuclear fusion happens on the sun. Not just the sun, all stars do nuclear fusion. Before we move on, let's talk about the fusion that's happening on the sun. The sun is made of hydrogen and helium. And so we get hydrogen atoms slamming into each other. Let's say that this hydrogen has a mass of 1 and this hydrogen has a mass of 1. Then we might create a hydrogen with a mass of 2. Sometimes these really light hydrogen atoms slam into each other and make heavier hydrogen atoms. These heavier hydrogen atoms hit more hydrogen atoms and then actually can create helium. So all the nuclear fusion reactions on the sun deal with hydrogens and heliums. Sometimes hydrogens slam into each other to make heavier hydrogens. Then those heavier hydrogens slam into more hydrogens, making helium. The most common fusion reaction on the sun is hydrogen atoms slamming into each other and making helium. One good thing about nuclear fusion, the products are not radioactive. That's what makes nuclear fusion cleaner and a better energy source than nuclear fission, where atoms split apart. When atoms split apart, they do release radiation, but the products of fusion are not radioactive. So why isn't nuclear fusion used more than nuclear fission? We've got some problems. And the problem is we go back to those nuclei being repulsed by each other. Since they're being repulsed by each other, remember I said it takes a great deal of energy to force them together. Well, when we talk about energy, we're normally talking about heat. To get these nuclei to slam together, it requires a very high heat and pressure. For fusion to happen, the environment has to be rich with energy. Very high heat produces that amount of energy. And since it requires such high heat, we cannot contain this reaction. We do not have a substance built that can contain the amount of heat and energy required and put out by nuclear fusion reaction. Could you imagine a world where we could control nuclear fusion, clean energy? Whew, I don't know if we're ready for that much power. Well, I hope you feel confident in everything nuclear chemistry. Until next time, bye y'all.